All right, guys, welcome back to another lesson. So this is called 4.2.2, and the next one's going to be 4.2.1, and the next one's going to be 4.2.2. The Algebra 2 teachers, all of us got together and decided that we need to take some time out and kind of review a couple fundamental skills from Algebra 1, things that you might be rusty on. So one of those things is the FOIL method. So this isn't a normal part of where this course goes. We're kind of just sidestepping for a couple of days and reviewing. As a result, there's 4 lessons this week, which is kind of heavy, but there's also no quiz this week. So a total of 4 things you're going to do. The 2 lessons before this one, and then tomorrow's lesson. Which are today and tomorrow review topics. So we're calling it FOIL because that stands out in a lot of people's minds. They remember doing this before. It's actually sort of a combination of different things. In general, you might call this multiplying polynomials. Oops, didn't mean to draw a line through that. Multiplying polynomials. And there's different ways this can be done. The distributive property, hold on. Excuse me. Oh boy, that came out of nowhere. Distributive property, which is technically not foiling, but it's still multiplying. The FOIL method is a type of multiplying. Binomial times a binomial. So this is where FOIL comes from. It's where you multiply the first 2 terms together, the outer 2 terms together, the ones on the far left and far right, the inner 2 terms in the parentheses, they're closest together, and then the last term of this one times the last term of that set of parentheses. So first, outer, inner, last, that's where FOIL comes from. And it's a way to keep track of everything that you're multiplying together. We're also going to get into multiplying a perfect square binomial, which is often done incorrectly by students. When students see a problem like this, what they tend to do is distribute this power and call their answer a squared plus b squared. That's actually not correct. It's 100% wrong. You cannot do that. So I'm going to be talking about that. When you square something, you multiply it by itself. A plus b times another a plus b. And when you do first, outer, inner, last, you end up with 4 parts of your answer, not just a squared and b squared. It gets a lot more complicated. I'm also going to mention something called conjugates. Conjugates look identical, except one has a plus sign, one has a minus sign. So when you FOIL these together, when I get to that example, you'll see why I'm making a kind of a big deal out of that. We're also going to extend it to a binomial times a trinomial. So bi means 2, so it'd be like 2 terms. Tri means 3 terms. So multiplying things like this together, they don't actually FOIL. They're bigger than FOIL. It's like first, middle, first, outside, inner, second, last, or something like that. I don't know. It gets a lot more complicated. And then a trinomial like a plus b times d. I'm sorry, a plus b plus c, d plus e plus f. Now you got to do this and this and this and this and this. And oh my gosh, it just gets crazy. Fortunately, you don't have a lot of those that you need to do, just a couple. All right, so let's get started on this. As always, I'll do the evens. Your odd problems are your assignment. So this starts out with just one problem for each of us, one for me, one for you, of the distributive property. Multiply a 7 into these parentheses. You get 56r. Multiply the 7 over here, minus 28, and that's it. Now keep in mind, we're not solving anything. This isn't the type of algebra where you isolate a variable that's not set equal to 0, nothing like that. We're just manipulating this. We're doing the multiplication, and that's it. So that would be the answer to number 2. And unlike yesterday, we actually have a real answer key here. I can check myself. So that's that. There's not a bunch of those. When we get to FOILing, that's a problem like this. So we're going to multiply the first term times the first term. X times x is x squared. Outer term times outer, negative 6x. Inner times inner, negative 3x. Last times last. First, outer, inner, last. Anyway, 3 times 6, negative times negative, positive 18. Most of the time when you do these problems, you do end up with a couple of like terms that you can put together. So this works out to be x squared minus 9x plus 18. Negative 6 plus negative 3, or negative 6 minus 3 is negative 9. All right, check number 4 real quick. And there it is. All right, so we're just going to work through these, and again, we'll get to some special cases like this one, and I'll make a big deal out of those. Otherwise, I'm just going to sort of plug along, follow along as you need to, skip ahead if you want to see some of the other problems. All right, so here, first, 56x squared. Outside, negative 35x. Inside, plus 24x. Last, negative 15. The middle terms are like terms. Keep in mind, this is not a like term. X squared is technically different than x, so you only combine the like terms. 56x squared. What is that? Negative 35 plus 24 is negative 11x minus 15. And there it is. So again, just a review of a fundamental math process, multiplying. All right, so number 8. 4p minus 1 squared. Again, this square does not distribute like that. That's not a thing you're allowed to do. You have to do 4p minus 1 times 4p minus 1. So first is 16p squared. Outside, minus 4p. Inside is also minus 4p. And last, negative 1 times negative 1 is positive 1. Again, we have like terms right here. They're the same. Not that it really matters a whole lot, but yeah, they're the same. So that's negative 8p plus 1, and there it is. Notice if you try to distribute that, 4p squared would be like, what, 4 squared? 16p squared minus 1 times 1 is 1. You do not get the right answer. And speaking of the right answer, speaking of being lost, no, there it is. Okay, so do not distribute the second power. It just doesn't work. You have to multiply the thing by itself. Number 10. Kind of a standard, just work it out, FOIL it, whatever. That's going to be 7 times 6, 42x squared. What's that? Positive 56x. 6 times 6, negative 36x. And minus 48. These two terms go together. 56 minus 36, 42x squared plus 20x minus 48. All right, so hopefully you do recall doing this. Not a big deal. A little worried about people, no matter how many times I explain it, there's still people who do this one wrong. Ugh. All right, number 12. So number 12 is what I called before conjugates. M minus 5, M plus 5. They're exactly the same, except one's a minus, one's a plus. Does that mean you treat them differently? Not necessarily. FOIL. First, m squared. Outside, plus 5m. Inside, minus 5m. Okay, that might look kind of interesting. And then last, negative 5 times positive 5 minus 25. Now when we do our like terms, plus 5m minus 5m, what happens? Well, they just cancel each other out, and you get m squared minus 25. Let's check that and make sure it's right before I say anything else. Yeah, right there. Okay, so it turns out if you have a problem with conjugates, if you can see that they're conjugates before you start, you're going to know, you're going to sort of be mentally prepared that your answer is going to be a little different. Terms are going to cancel out, and you'll end up with an answer that just looks a little smaller. Oops, I didn't want to do that. Your answer just works out to be a little smaller. Good grief, Haskell, come on. Than other problems. If you notice, all the other problems have 3 terms, 1, 2, 3, and this one only has 2, 1, 2. So that's a thing. It's not a make or break. You still FOIL it. You still do the same work. I just thought it's worth mentioning that it's slightly different. Okay, now we get into the binomial times trinomial. 2 terms times 3. So here you really need to keep track of things. So I'm going to multiply those 2 terms, 28a cubed. Now I'm going to continue with that 7a, multiply here. That's minus 14a squared. And then distribute all the way to there, minus 28a. So now I've done this term by all 3 of those. I'm technically halfway done. Now I need to do, this term times that one. 4 times 4, positive 16a squared. And then here, 4 times negative 2, negative 8a. And here, negative 16. At this point, look for like terms. 28a cubed. There is no other term that has a cubed in it, so we're not going to mess with that. However, let me change colors. 14a squared negative plus 16a squared, those go together. Negative 14 plus 16 is positive 2a squared. Change colors again. Let's go with green. Minus 28a minus 8a. Minus 28 and minus 8 is minus 36a. And then finally, one more color, pink. That minus 16 does not have a like term, so you just bring that down. And that would be your final answer for number 14. Let's check. There it is. And hey, look, we're almost done. Number 16, trinomial, 1, 2, 3 times another trinomial, 1, 2, 3. Now, if I gave you like 10 of these for homework, you would be allowed to hate me, absolutely hate me. You might not like that you have one of these, but it's not as bad as doing 10 or even 5 or something like that. So we'll just get through this. We'll multiply those two terms, 24 n to the fourth. Then those two, negative, what's 6 times 8? 48n to the third. So that's squared, and that's technically 1. 2 plus 1 is 3, so that's n to the third. And then here, negative 6 times positive 6, negative 36n squared. Now I've used up that first term. Let's do the next term. Negative 2n times 4n squared. That's negative 8n to the third. Again, 1 here, 2 there, adds up to 3. Distribute here. Negative 2 times negative 8, positive 16. N times n is n squared. And let's go there. Negative 2 times negative 6 is plus 12n. Now, am I out of room? Almost. We're done with that term. I'm going to go underneath now. 7 times 4n squared, that's going to be plus 28n squared. Right here is negative 7 times 8, 56n. Give me a second here to make this a little better. Slide it over. There we go. Let's go here. Positive 7 times negative 6 is negative 42. So there, I've done every possible multiplication. I've used those little arrows or arches to connect them together. Now I look for like terms. I don't think I'm going to get all crazy with a highlighter. 24 n to the fourth is the only n to the fourth term. I'll just use the same color. I'll go with yellow. Here's an n to the third. Here's an n to the third. And that's it. Negative 48 minus 8 is negative 56 n to the third. Now we go to n squared. Negative 36n squared plus 16n squared plus 28n squared. Oh, good grief. Negative 36 plus 16 is negative 20. Negative 20 plus 28 is positive 8n squared. Now we've got plus 12n minus 56n. That's what? 12 minus 56, negative 44. Negative 44. And use a calculator if you need to. And then bring down the minus 42. And that should be the answer. Now, it's always scary when I do math in my head and I maybe rush or get nervous about it. Did I make a mistake? Bing, 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 bing. Looks good. So there it is. Okay. So all of this should be review. When you get down to 13 and 15, yeah, it's a little more of a struggle. Do your best. I have faith that you can do this. Be sure to show your work where applicable. Contact me if you have questions.